Adding, subtracting, multiplying, or dividing? Multiplying. What does quotient tell us? The answer to addition? Division. Good. They said addition, and I was like, no. All right, quotient is for division. So if you want to write division there next to it, or divide, you can.
Addition is sum.
Means that we're going to be dividing, and we're going to be using this fraction line for dividing today. When we see this division, remember that fraction line really tells us that we are dividing. All right, as we open it up, we're going to start with an easier problem. So I'm going to open it up. I'm going to write on this inside flap, which is why I didn't want to glue it in, but I did already, so that's the way life goes some days. All right, if I have x to the third power divided by x to the seventh power. This is going to be the one that we write out, and we show what those x to the third power, x to the seventh power means. Those big ideas. Alan, I put yours right next to your bag. Is the glue in? All right, so if I have x to the third, what does that tell us? Good, I have 3 x's. It's going to get a little crazy there because... All right, on the bottom in the denominator, I have 7 x's, so x times x times x, 7 times. Now, anytime that I have a number divided by itself, no matter what that number is, if I divide that number by itself, how much will we get? What? Any number divided by itself is always what? 1. So if you want to, you could take out a colored pencil if you'd like to just show this. That x over x that really equals 1 times x divided by x is 1. And how many x's become 1s? 3. When I multiply by 1, do I have to show that I'm multiplying by 1? No, if I'm writing 1 times 4, do I really have to write 1 times 4? Can I just write 4? Just 4. Okay, so how many x's am I left with? 4. But where are the x's located, in the numerator or the denominator? On the bottom, the denominator. So I need to show that that's over something. What would be left over in my numerator? What number could I always write in my numerator? 1. All right, so as I take a look back, we're going to come up with our property now, our rule that we're following. No, do the notes. You're not even doing the notes yet. Do the notes. Come on, man. To divide powers with the same, what matches, bases or exponents?
Bases.
The bases, those variables, so same bases. What are we going to do? How could we have gone from 3 and 7 to just 4?
7 minus 3.
Yeah, we do 7 minus 3. We subtract our exponents. We do need to decide where the leftovers are. So after we subtract those 3, there's 3 1s. So we started with 7 x's. We took away 3 of them because they matched. We do need to decide, do they end up in the numerator or the denominator? Where did we have more x's to start? In the bottom. So that's where they ended up, in the denominator. Good. All right, so if I have x, a to the x power over a to the y power, we would write that as a to the x minus y. If this part doesn't make sense to you, the words might make more sense. This is kind of one of the times in math where, to me, when it's all variables here, I'm like, what? Okay. The words make more sense to me in this case. Most of the time, math makes more sense, but I don't know, it's kind of goofy. All right, I'm going to use 2 color pencils. If you want to grab out color pencils, you can. I'm looking, or you can use highlighters. Okay. I'm looking at our m to the 5th, p to the 6th power, over m to the 3rd power, p to the 11th power. So when I look at these fractions, I'm matching my numerators and my denominators. So I'm going to be looking at our m's, and then I'm going to be looking at our p's. All right, so for my answer, I'm going to look and say I have 5 m's in the numerator and 3 m's in the denominator. So how many m's will make ones? How many of them have a match? 3 of them have a match, which means how many am I left over with? 5 minus 3 would be 2. And are those 2 m's, am I going to have them left over in the top or left over in the bottom? Where did I have my extra m's? In the top, in that numerator, and we had 2 extra m's, so m squared. Okay, if it helps you to write out that process, we did 5 minus 3 equals 2. All right, what about my p's? What do we get? How many p's would we have left over once we subtract? 6. 11 minus what? How many? I said 6. What did you guys say? What? 11 minus 6? Yeah. 11 minus 6 is 5. So we're going to end up with 5 p's left over after we make the ones. And where are those 5 p's going to end up? In the numerator or the denominator? Where did I have more? The 11 was on the denominator, so we have p to the 5th power in the denominator. Okay. All right, next up we have power of a quotient property. So kind of goofy here. We have 2 words that are really similar, or 2 properties. We have quotient of powers. That means I'm taking a quotient and there's powers on top and bottom. Power of a quotient means I have a quotient, I have a fraction, and then we're taking a power of that quotient, a power of everything. Okay, and this is really similar to what we saw before, so I'm going to open up that flap. We're going to show that example. All right, if I have a squared over b, all taken to the 3rd power. That would mean we're taking the inside amount how many times? Oh, you're taking the a 2 times. But the a squared over b, how many times are we doing that? 3 times. So we would say a squared over b times a squared over b times a squared over b. Now, when we multiply fractions, we multiply straight across. So when I have a squared over b times a squared over b times a squared over b, I'm really multiplying our numerators together. So what does a squared actually mean? A times a. So I have a times a times a squared, a times a squared, a times a. And on the bottom, I really have 1, 2, 3 of those b's. So b times b times b. All right, so as I take a look at that, how many a's do we end up with in the numerator? 6, so a to the 6th power. And in the bottom, b to the power of 3, or to the 3rd power. So how could we have gone from our problem to the answer without having to write everything out in between? Where would that 6 come from? Good. The a had a squared, and 2 times 3 is 6. How have I gotten the b to the 3rd power? Good. When we don't see an exponent, how many b's is that saying? 1. So 1 times 3 is 3. So we're still multiplying. Good. So we're going to multiply all the exponents in the numerator. Try and write that word small, because I didn't give you a lot of space. And what does numerator mean again? The top. So if you have room to throw that in there, the top. We're going to multiply all the exponents in the numerator and the denominator. And denominator means the bottom. And we're multiplying it by that outside exponent. So again, this one is that similar to that distributive property, that idea that we're taking that outside exponent, that k, and we're going to multiply it by everything on the inside, the numerator and the denominator. Okay, and then this was supposed to be a y, not an x, because then that would change everything if it was an x. So make that a y maybe, if you can. That would be great. All right, so this is going to be x to the a times k. And then on the bottom, we have y to the b times k. Again, that bottom one was supposed to be y. That was my fault. Shouldn't have made copies yet. Forgot. Change it for next year. All right, so as we take a look at this one, we could write this out. We could write it as 3y squared over 5x to the 3rd w times 3y squared over 5x to the 3rd w times 3y squared over 5x to the 3rd w times 3y squared over 5x to the 3rd times w times 3y squared over 5x to the 3rd w. We could write it out 5 times, and then we could count how many of each thing there are. We could even go further and write it as 3 times y over 5 times x times x times x times w times 3 times y over 5 times x times x times x times w. But I'm not going to write that all out. I'm not going to say that all out. Instead, what we can do is we can take that 5 is on the outside, and we can multiply all the inside exponents by 5. Now, here's the problem with this, or not the problem, but the thing that's really important to remember is everything has an exponent. All right, what is the exponent of the 3? Nope, not that 3. The 3 on the top. What is the exponent of just 3? Yeah, 1. We need to make sure we fill in those numbers. So we have a 1. Y has an exponent of 2. That 2 doesn't belong to the 3. That 2 only belongs to the y. Okay, so on the bottom, what needs an exponent still? The 5 needs an exponent. And what else? The w. So now we're going to multiply everything by that 5. I don't like drawing in those lines. If you like to, you can. Those lines, to me, at this point, there's just a lot. All right, so it's 5 times 1. 5. 5 times 2. B to the 10th. 5 times 1. It's 5. What's 5 times 3? 15. And 5 times 1? 5. I screwed that up. I put a W there. That was supposed to be x to the 15th power. And then w to the 5th power. All right, we're not quite done yet. We're really close. Whenever we have numbers with exponents, numerical values, like 3 to the 5th power, we do actually need to find that. When we have a fraction, we also need to check to see if we can simplify it. So what I'm going to do is in my Desmos calculator, I'm just going to put 3 to the 5th power. And I'm going to right away just say divided by 5 to the 5th power. And originally, this is going to give me a decimal. We don't want a decimal. So I'm going to hit that fraction button. And this time it actually turns out exactly how it would have been if you said 3 to the 5th and 5 to the 5th. But in case there was a point where it had to simplify, this would have done it for me, and that would have been a nice way to just kind of get rid of some steps. So we have 243. Apparently not writing numbers right today. In the numerator, along with this y to the 10th power. And in the denominator, we have 3,125. X to the 15th power, w to the 5th power. And again, to find those, you can just use your calculator, put them in. If you did it separately, that would be fine. You would just do 3 to the 5th power. We get 243, 5 to the 5th power. All right, that is it for your notes today. Pretty short. So today would be